Welcome back to another HVAC Engineering-Techie training video. Remember, these training videos are educational in nature and intended to help your career. Today's lesson is on the technical commissioning process for HVAC and controls. This video is the process, the basic process of technical commissioning. It's a little long, but I try to put it all in one because it is giving you the overall plan of what commissioning actually is and how you perform it. So before we start that, I'd like to ask you a really big favor, and that is if you would become a subscribing member if you haven't already. Hit the button down below, give me a thumbs up if you like these videos. It's painless to you, it costs you absolutely nothing, it's free. But it's very important to me because Google uses that data to evaluate these videos and actually keeps me on the air. So remember that HVAC Engineering-Techie is your place where all things HVAC are discussed, including engineering design, construction equipment, systems, tab, controls, energy, and performance. So I hope you enjoy the video. Thank you. So today we're going to talk about technical commissioning of HVAC and controls. So these training videos are basically, the commissioning training videos are based upon the process found in the ANSI NEB Standard 110 2018. For the technical commissioning process. This is a standard for which I was chair of the ANSI Development Committee, and it took us a year to write two standards. One is on new building commissioning, which is this 110, and another one called 120, which is retro commissioning. I'm actually really proud of these standards. They're the only standards in the marketplace for technical commissioning. It tries to explain the difference between regular commissioning and technical commissioning. Now, this is might be of interest to you, but I basically started in commissioning for NEB in about 1992, but I actually had been commissioning for several years before that. And so the commissioning process originally was done in industrial processes where people it could be dangerous if it wasn't working correctly. So these processes were fully developed way before commercial air conditioning started being commissioned. So the only thing I wanted to say is that all the processes that are shown in here, I've actually tested every single one of them. Before if someone suggested it should go on the standard, I actually tested it in the field to see if it was better or not. And believe me, these processes, even though some of them may appear to be difficult, they will absolutely deliver a working building, which is important. So here, let's take a look. Let's go see what's happening here. Other important CX training videos. Okay, so now this process has several videos. This one is Cx-1, which is the technical commissioning process, overall process. Cx-2 is the HV technical site inspections, how you actually do site inspections. Cx-3 is pre-functional tests, which tells you how to develop those tests and how to perform those tests. Cx-4 is point-to-point tests for control systems, really important to do. And this explains how to do them and what the process is to do that. HVAC functional testing, which is like I like to say, this is what separates the men from the boys or the girls from the women on how to actually do testing. This is the functional test. This session teaches you how to write the scripts and how to perform the test. Commissioning of tested balance is Cx-6, which, remember, that tested balance also needs to be commissioned, and it can be somewhat controversial on how you do that, but this is actually how you actually do it. And Cx-7 is control systems commissioning, how you actually commission a control system. And this is really important because when if you take a survey of all the sites that have problems, 99% of them will all be blamed on the control contractor. Maybe done rightly so, maybe not. But anyway, it's an important one to be commissioned and it be commissioned correctly. Cx-8 is the continuous performance tracking system, and you'll understand what that is when we get through with this session today. So those are the actual ones we've laid out. We may actually develop more if you see the need for it, but if you see a need for something, just put a note down in the comments and I will respond. Okay, technical versus process commissioning. So what's the difference? Now, process commissioning, unfortunately, when ASHRAE got involved in the process, They dumbed the process down to be easy to do, low cost to do, but unfortunately also made it not do anything. So we're going to vary that. Now, it's not that those people aren't smart, and those people are certainly capable of doing a technical process, but they don't, and that's very unfortunate. So this is the difference between technical process. The person who wants to do process commissioning, I don't have a problem with that. It's just not as good as technical commissioning. And what I find comical is every customer gets it. They get it immediately, but all the engineers don't seem to get it, and I don't understand, since they're the technical people, but they don't get what technical commissioning is, and I don't understand. But customers do. They get it immediately. So process commissioning provides commissioning management to the contractors on the site in an effort to deliver a better performing building, and I think it does help. But it is a management process. Technical CX also provides the commissioning management, but it adds independent third-party testing of systems to ensure system operability and performance. So in a technical commissioning world, you're out there actually testing systems, and you don't rely on somebody else. Technical commissioning has a process that's first-hand knowledge because I observed it or I actually tested it myself. Whereas the management always has somebody else doing it, and you're taking their word for it, which is in construction is dangerous. Process commissioning utilizes sampling strategies to lower the cost of commissioning services. Sampling has contractors test only a small percentage of the system and uses statistical analysis to judge the total functionality of the system. Now, I understand the science they're using here, but it doesn't actually work. Theoretically, sure. But I ask every one of those guys, would you ride in an elevator that's been sampled? You know, maybe you're on the one that it's not actually been tested, but statistically it should be the same as the others. No, and the state won't let you because they mandate they all be tested. Well, it's the same thing. You know, if life is in danger, you will certainly never sample. So whenever a customer says, well, we want to lower the cost, so we want you to sample, then we ask, well, what is your failure rate? What a failure rate will you accept? They say, well, none. I said, then you can't sample. If you want it all to work, then you need to test everything. It's really simple, but unfortunately some people don't get it. Technical CX provides third-party testing of 100% of controls and mechanical systems to ensure all systems are operating correctly and fully functional. We're not going to take a chance that something is not working because we didn't actually test it. And this is one of the reasons why a lot of people don't do technical commissioning, because it is work. You just can't fly in and spend a few hours and everything's good. No, it takes some time and labor to get this done. All right, so what are the activities prior to the project design? First, you got to get a contract, right? And who do you work for? Well, this is an interesting subject. The best is, of course, you should work directly for the owner, because the effort you do, you are actually an advocate for the owner. So you should be right there underneath him. The other thing that's important, as a commissioner, you have lots of responsibility but absolutely no authority. Nobody works for you on this project. So basically, the only authority you have is through who you're contracted to. And if you're contracted to the owner, he has all the authority. It's his project. So when you're contracted directly to him, you're at the right place. That's where you should be. General contractor is certainly possible, especially if they're a CM at risk. You know, if they have the actual risk for the project and the owner is a little more outside that deal, then the general contractor is a good fit. But on a regular project, he is not a good fit, because what happens, and I've done it all these ways. So it's a low authority over design. If it's a bid build design, the general contractor is not responsible for the design, so he pays attention to everything that's in his silo, in his envelope, but doesn't pay any attention to anything else. So then you'll have to fight through that the general contractor, if he's ignoring anything on the design side, you would need to get it. So anytime we take a contract to the general contractor, we have a clause in there that says we are working for the general contractor for the ease of payment stream for the owner, but we still report to the owner. All reports, all knowledge, all actions will go directly to the owner. And that gives us this thing with not trying to have any conflict of interest. I have had jobs where the general contractor was a big conflict of interest, and it was a fight. I mean, he wouldn't give us submittals. He wouldn't give us any information until it was forced on him by the owner. The comical thing about that is when the job was over, I got a call from him, and I thought, oh boy, he's mad about something. But no, he called and said, how can I get you on all of my jobs in the future? And I like to fell over, and I said, well, why? And he said, well, you commissioned the MEP, mechanical, electrical, and plumbing. And those are the only disciplines that were done on time and had no warranty issues, no callbacks. Everything else was a disaster. And I said, okay, well, I explained how to do that. Didn't happen, but I thought it was interesting. Any designer, maybe you can work for the architect, maybe you can work for the mechanical engineer. These are terrible places to be contracted. It's not that they aren't good people and they aren't smart people, but they have a low authority over different people, and you can have a serious conflict of interest. So trust me, it's best to be up with the owner. Now, some people try to perform it at a sub-level. Impossible. Should never, ever even consider that. Say like, well, I work for the mechanical contractor. That's foolish. No, should never do that, because your line of authority is zero over anything else. So that you don't ever want to do that. Now, you need in your contract, you need to tell me, make sure that what systems are we commissioning, or are we only doing a part of a system? You need to define that very clearly. You need to define your responsibilities. Are we doing total technical commissioning, or is there something else we're doing that is slightly different? I mean, it's possible. Extra for delayed or multiple test failures. You need to have a clause in your contract that protects you from contractor failures. Now, most contracts have in them that as a commissioner, you're obligated to test the system and then test the correction. That is an obligation that you should have. But if you have to test it 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th times, those are above and beyond, and someone else should start paying. Because remember, you're a technical commissioner, you're actually spending labor doing this stuff. And if the contractor is not paying attention, someone else should pay. And this is where it pays to be contracted to the owner, because now the owner can just withhold the cash from the draws to get you paid. And I told you this before. Remember, you are a hired consultant and have lots of responsibility, but absolutely no authority. So that authority must come from others. It's always from who you're contracted with. Now, there's a thing called the Owner's Project Requirements, the OPR. And this is a document that is required to be created by the owner. And it actually describes their desires for the construction project. What are they after? What do they want the building to look like? What contents they want to have in it. And we'll go through that in a little bit. But be truthful, you're going to have to help, because most owners don't know exactly what to put in the OPR. So what we normally do is we give them a questionnaire that actually asks all the questions what should be in there. They can say yes, no, or give an answer. And then the OPR can be built from there. Now, this is some of the stuff that goes in here. I'm not going to go over all this in detail. It is in the standard, of course, the design method, the contract type, description of the program methodology, design deliverables, desired project schedule. All these things are important to them. The BIM requirements, commissioning requirements, building parameters and characteristics desired by the owner. Maybe what's marble on the outside, who knows. Building type and size, use and occupancy, aesthetics, historical preservation. Maybe it's an old building, they want to preserve something, and a future adaptability, or maybe it's supposed to be expanded in the future. Comfort parameters such as temperature, humidity, sound, vibration, ventilation, light. If these are really important to them, if it's a museum, those conditions would be much different than if it's a warehouse. It'll be a lot different. Control system sophistication, measurement and verification requirements, size, zoning, codes and standards, size master plan and future expansion, coverage density for the site access, utilities, parking, and all of these things that you see here is going on, that they need to put that in there so the designers and the contractors will understand, well, this is what we're trying to end up with. Indoor air quality standards, emergency response access, HVAC system components, DDC control systems, components, electrical, plumbing, refrigeration, fire protection, life safety, security and access, data and wireless infrastructure, communication systems, vertical transportation, open operation and maintenance, and other things they put in there. Let's say that they happen to be a Johnson Controls user, and they have many buildings all with Johnson Controls. So they actually say, I want Johnson Controls in this new building, which precludes the competitive bid process, but still, that's what they want. Hey, it's their money. They should get what they want. Create commissioning specifications. Okay, so in every contract document, we put out some specifications, but these are not what normal specs are. Normal specs are there for the bidding contractors to know what they have to do, but you were probably already under contract before those contractors are already on the project. So the specifications need to be written to match your process. So they tell the contractors what you're going to do on the site. So to do that, you really need to do the specifications, to create the specification to give them to the architect to put in the job, or else you'll have to take the architect spec and redo them to meet your standard. Trust me, it's much easier just to give them the whole thing and say, here's the standard. This is the specs that meet the standard I'm going to use. And the specification, I'm going to use a CSI format. So 01-9113 is a general commissioning process. 01-9119 is building enclosures. 1108 is commissioning of refrigeration. 1408 is commissioning of vertical transportation. 2108 is commissioning of fire suppression. 2208 is commissioning of plumbing. 2308 is HVAC. 2608 is commissioning of electrical. 2708 is commissioning of communication. 2808 is commissioning of safety and security. 4208 is commissioning of process systems. 4808 is commissioning of power generation systems. And there are others. These are the general ones. You may have controls, maybe out in 25, section 25. May have an integration platform. You put that in 25, and then you have another control section buried in 23. And you just add whatever you need. But these are the general specifications. And several of these things may not be in your scope. So if the owner doesn't want you doing any of this, those are not in there. You only put in the sections of what you're going to do. Activities during project design. Okay, the plan. You have to create a commissioning plan, and this, as a commissioning provider, it's your job to do that. List the commissioning activities of the project, identifies the systems to be commissioned, identifies the commissioning provider, CXP, team members, defines the roles and responsibility of each commissioning team member, provides duration schedule for the main commissioning activities, establishes documentation requirements, establishes required meetings and communication protocols. So this is the general commissioning plan, and this is always done after everyone's on the job and everyone has a contract. And this is when you start putting a plan together that brings everybody together. So remember, the commissioning is not just you alone. You have to have a lot of other people that are involved in that project as part of this team to make sure to actually get commissioning. The commissioning team is made up of the following. More or less members may include if required. The commissioning professional, which is you, the commissioning team, the owner's representative, the owner's operation teams. Those operators should be involved if they're going to be operating this building. It's really good to have them involved in the construction process. The general contractors team, the design team for each commission system, the QC representative for each commission system contractor, that's quality control, the tab contractor representative, the control contractor representative. These people are all a part of the commissioning team, because everything that you're going to commission, these people are involved in. And so it's good that they're on your, especially the control contractor and the tab contractor really need to be involved in it. All right, so the first thing you do after the plan is you do a commissioning focused design review. Now this is not a peer review, this is a design review, so you're trying to see how well the design is communicated. Can you, as a professional, understand these drawings and know exactly what you're going to build and how you're going to test it? If you can't understand that, the contractors won't be able to understand that. So this is what you're doing. You're actually seeing, is everything on there? You're not doing a peer review. You're not evaluating the quality of the engineer's processes. That's his business, not yours. But you are making sure that everything's on the drawing and they do all match and the coordination is correct. And what you're actually doing, here's the reviews you can do. You could do less. You could do fewer reviews and just crunch these all together. But maximum reviews would do a 35% design development review, which is a basic review of system selection and layout, just to see what the systems are going to be. There's no details here, so you can't tell much. A 65% DD review, which is a detailed design review and CX specifications are added at 65%. So at 65%, all equipment should be specified. You should see the whole general system, maybe not all the details yet. 95% DD review is the design detail verified. So at 95%, the drawing should be essentially complete with just a few things to correct before they become construction documents. And then the fourth review is 100% construction contract documents, CDs, and your final verification of the changes. So this is the set that's going to go for construction. So at this point, you're verifying that any changes that were recommended earlier actually got in this design. It's not uncommon for you to go through 65%, find some serious things wrong that need to be corrected, and the designer totally ignores you. That is very possible. I'm used to getting ignored, but at that point, you need to go back to the owner and say, look, these are important, and then he may have to force the designer into taking care of those. It's just, unfortunately, life is life. I mean, the commissioning process is an easy process if it weren't for people. If you didn't have people, it'd be a really easy process, but people make it hard. Sometimes they just have other things that are important to them besides what your importance is about. A basis of design review. Now, many people are really confused about a BOD. The BOD is created by the designers in response to the OPR and is reviewed by the CXP and the owner, but is not created by them. The BOD is created by the designers. I've had many jobs where the owner asks me to do the BOD, and that's not my scope. I didn't do the design. I can't actually do the BOD, and you'll see why. The BOD contents states how the design achieves the owner's requirements as listed in the OPR, lists the codes and standards utilized for the design, includes sustainability goals and levels achieved by the design, reviews alternate systems considered, and I wouldn't know any of that, so they have to do that. Okay, activities during project construction. First thing is you need to review the submittals. Now remember, the construction process has a process of reviewing submittals. Submittals comes from the providing contractor into the general contractor. The general contractor reviews them supposed to review them to compliance to the specification. They then go to the designer of that discipline, and he has to review them in detail and approve them or not approve them, ask for a rejection, and then it comes to the commissioner. Now, a lot of times the owners, because they're always in a hurry, ask us to do them concurrently with the designer, which is possible, but not best. And the reason is because the designer has authority over their specs. Remember, you do not, or those submittals, you do not. And if you do it at the same time and you find a big issue that he misses, now he's got to do it again, or vice versa. If he finds a big issue you missed, now you got to do it again. I'll explain what you're looking for that's different than the designer, but so if you do it concurrently, it can, number one, issue some confusion, and it can require a little longer because you may have to get in and do a communication a little bit different. So it's really best that you review it after the designer, because you get to see the designer's comments then and see what he was looking at. So the CXP or his team performs the following submittal reviews: compliance to the OPRs, number one, accessibility, maintainability, commissionability, and industrial best practices. Now, those all seem like catchphrases, but it's really what you're doing. The engineer's looking into this meet what he specified. Is it the right size? Does it have enough BTU capacity? Those are his main concerns. Yours are totally different. Yours is now, is this system the right size? Can it actually be accessed where it's going to go? Is it maintainable? Is there anything here? I've had jobs where you can't get the filters out the doors. So it's not maintainable. Commissionability, can we actually commission this? And normally it's always yes, but you need to make sure that. Can it be tested and balanced? Is there enough things in there for the tab to happen? And is this the system the best for industry best practice? The best practice is a little bit of a shady area, but you can't use it when you see something that's not correct, and you need to get that submittal. So your data for PFT creation, so you're going to be creating some check sheets eventually, and you can use this submittal data for that, and that's why it's best for you to be after the designer. Now, there is one caveat in submittal reviews. Submittals normally don't have just one-time review. They may take 4, 5, 6, 7 reviews to get everything correct in there, because there's a lot of people reviewing them. The owners reviewing them, the designers reviewing them, affected other subs designer reviewing them, and the general contractor reviewing, and you're reviewing them. These can cause a lot of reactions, so you got to stay up on the revisions to make sure something's not happened that might affect what you're looking at. This is just saying that you should look at them after the designers looked at them. Okay, the contractor's quality control program. Each contractor should have one or more trained and experienced technicians who are assigned to be a part of the commissioning team who are responsible for contractor quality control program for the commissioning process. So you want the contractor to assign one senior level technician that understands everything about his craft and can answer the questions and help you coordinate the commissioning of his craft. That's really important. If you don't do that, just anybody can wander in from that contractor, and say, yeah, I'm here for the contractor. And he may not have any really good line of communication for that contractor or no authority for that contractor. So you need to have them tell you who that person is. That individual should bear responsibility for the contractor's support and coordination of the commissioning process of their work, which shall include creating or assisting with the creation of their system pre-functional test sheets, performing their pre-functional check sheets, assisting the commissioner with corrections or compliance issues with the PFT tests, that's pre-functional tests. So basically, the contractor is actually doing that. You may be observing every once in a while, or you may be checking it and see some problems. He is the guy responsible to get those corrected and get to you. Another big problem here is actually getting the sheets. Now, I come from a paper-based area. I have used some automated cloud-based systems, which are fine. The cloud-based are good because you can see what's missing right away. In paper, you have to go look yourself. So this is always a problem is, we want to complete, but we can't complete because he's not complete. PFTs, pre-functional tests, have to be done before you can move on to other things that have to happen. So they need to get done on time. Pre-functional check sheets. PFTs are either installations, and this, I apologize for this, but this was caused by ASHRAE, which has actually led this process of the numbers and all that stuff. The PFTs can either be installation inspections or they can be startup inspections. So there's actually two kinds of pre-functional tests. So the CXP creates a PFT check sheet and the contractor performs them. Installation check sheets verifies the correct piece of equipment is installed in the correct location, that is installed correctly, and that it has adequate access for maintenance and operation. Once the installation is verified as complete, it is ready for startup. So, you need to make sure everything's correct. And the contractors normally have a pre-startup checklist. Well, this can become that list, but it doesn't have to be. But these need to be done before they start the system up. So one thing, I don't know if you caught in the beginning of this, process commissioners will say that the contractor makes his own check sheets and does them, and the commissioner is really not responsible for any of that except showing him how to do that. The problem I found with that is a lot of contractors, their field technicians only know a piece of the system. They don't know it all, and they may not understand how to create a check sheet. Now, I've always told subcontractors, if you have a system that you've developed in-house to do all this, then give me a copy of it so I can actually see if it's robust enough. And 90% of the time, it is not. It's superficial at best. A lot of guys have just taken the equipment manufacturer to take his first pre-list list, which does not include operability, maintainability, all that stuff. It has just to do how do you get it in the air or on the ground and get it ready to start up. But so you need to make sure they're robust enough for that. The CXP or the contractor creates the PFT check sheet and the contractor performs them. Now in the beginning, we as commissioners performed them all ourselves. And that's very possible to do. It just takes a lot of labor to do that. And the reason we did it, we were actually the contractor. I used to be a large contractor, mechanical contractor, back when commissioning first started, and we did all this ourselves. And I got to tell you, the commissioning process, the technical commissioning process, does help deliver a better building. I knew that because I watched our warranty recalls go to nothing. We'd fully commissioned a building ourselves, and our warranty cost went to nothing because it was all done correctly. So the startup check sheet documents the startup process by recording key startup parameters of the system. Once the startup is complete and verified and tab work is complete, then the system is ready for functional testing. Contractors or vendor startup documents should be attached to the PFD check sheet. So startup, I don't probably have agreement with a lot of people on this. Startup is very important, but I believe you as a third party watching them start it up, they don't provide any value. Unless you're an expert on starting up this machine. I've started up a lot of pieces of equipment, but I still would not interfere in that process. So I basically say, contractor, you need to do these tests. Now, the startup tests have something in them that's important, and that's actual data. So they take all the electrical data, all the set point data, all the mechanical data that has to, and actually is in that form. So you'll have volts, amps, set point data, pressure data, all that kind of stuff will actually be in there so that everyone can see what it looked like when it was brand new. It's really important. So, 10 years from now, the owner's having a little issue. You can go back and look at this report and say, this is what this machine looked like when it was brand new. So now we can see what it is today. Commissioning communications. Communications on a project is really important. You need to make sure that the people on the project view the commissioning team as an assistant. You're trying to help them. If they see you as just an inspection outfit out to actually cause them issues, you'll have problems. So you need to set the communication system up so that they understand they have a voice and we're all working for the same thing. There are formal and informal lines of communication for each project. They may include any of the following. Kickoff meeting, which is really important. This is the place where you have a start of getting to know the contractors and for them to get to know you. The commissioning plan, that's a communication document. Field observation reports. You're going to be producing many reports of what you've seen in the field, and the way you do that will be important. Now, the one thing that we always recommend in your field reports, that you always, if you have an issue, you always phrase it as a question. Don't make a statement. The statement irritates people, and people seem to think that you think you're an authority, where you may actually be. And my saying is always, the commissioner needs to be the smartest guy in the room. If he's not, make sure you use questions, because questions, you're asking a question. Well, an authority doesn't ask questions. That sounds funny, but it's important to get people on your side. The issue log. Issue log is really the process where you manage your project and how you manage the issues to get them resolved. Periodic commissioning meetings. This is another thing about difference between process and technical commissioning. In the standard 110, we actually state that a project, when it's done, there should be no unresolved issues on the issue log. They should all be resolved. That's easier said than done. Process commissioners say that's not their job. Their job is to find the issue, not to make sure it's completed. We think that's totally false. And I've seen projects that have 30% of the issue log has never been resolved or even addressed, and that's not acceptable. So we actually tell people that every item has to be resolved. Now, one resolution can be the owner said, okay, don't worry about that. That cost too much money. We're not going to do that. He just resolved it. I mean, he's the guy's got the authority to do that. So your commissioning meetings, we'll go over that, is a way of communicating. CX workshops, if you have a big problem you need to work out, have a workshop that works well. And then, of course, emails. Everybody emails back and forth. It's a way of communication. Test reports, that's a way of communicating. Letters. Now, you don't have to do this, but I actually only use letter correspondence to alert everybody that I have found a life safety issue. Now, why would I do that? I can still make it just an issue log. Well, I'm limiting my liability. I'm doing a letter, a formal letter, that documents I found this problem, and if you don't correct it, it ain't my problem. So it's limiting my liability. And I've only written a letter on one project in my entire life, but that's what I do with that. Commissioning reports, that's obviously a way of communicating. Shared file transfer sites, you have that data, you can transfer data that direction. And your GC construction schedule is another communication item. So let's look at commissioning schedules. Remember, the general contractor's in charge of the schedule, not you. So the general contractor is responsible for the construction project schedule. The CX team provides duration schedules for CX activities to the GC for inclusion in the overall schedule. The CX team shall assess with the following schedule. Your site inspections during installation, how many you're going to have, when you're going to have them, and you can give that to the general. Now those are concurrent, right? You don't have to have special time just for you. So those will be concurrent with the subs schedule. Your pre-functional test check sheets, completion for installations. You'll tell him how long that's going to take you, so he knows when he's going to get submittals, and he can put that duration. Again, it's concurrent. Pre-functional check sheets start and completion. So when is the contractor to do these sheets? How long should it take him? Again, that's concurrent with the contractor. Control system point-to-point test and startup completion. That's you can give him how long that's going to take. Control system graphic completion. Now these come from the control contractor, of course, but these are certain durations that you need to see, and everybody else does, because if this is not done in time, we can't actually test. So that's really important. 6, functional testing and startup completion. Now this is really important. You give it a SIM because this is not a concurrent schedule. Functional testing is always critical path, and the reason is we have to do functional tests once the job is almost 100% done, but not occupied. So what happens on a lot of jobs is the construction slips during the construction process, but their startup, this turnover date doesn't change. So what happens, they start compounding that effect, and they crunch down the end date, so you as a functional testing don't have any time, and they want you in functional testing while it's operated with the occupancy, and it can't happen. And the reason is because we take the building totally out of control. So if your customer doesn't mind getting 85 degrees and 70 degrees and it gets noisy and it gets quiet, well, certainly we can do it with them occupied, but they won't like it. So trust me, you need to be, functional testing needs to happen at the end of construction before occupancy, and you need to make that very clear to the general contractor that this date for functional testing cannot be reduced. It's very important that they understand that. And owner's training verification. This is how and when you're going to do owner's verification. You're not doing it, but the subs are. You're simply verifying it, but you want to make sure that's on the schedule. Now, the commissioning kickoff meeting is an important event. It's one of the things you have to prepare for. It takes some time. The commissioning professional to attend and lead the meeting. It's your job. Review the commissioning plan with the team. Review the various commissioning activities and schedules. Review the documentation requirements. Establish communication and reporting procedures. Distribute contractor check sheets. Review the check sheet requirements and procedures. Answer any questions. Prepare and distribute the meeting minutes. So this is your meeting. You're in charge of it, and how well you do this, it will tell everybody how professional you are and what you're going to do on the project. I normally did this with a PowerPoint presentation in front of all these people so you can get to it quickly. They understand it better because there's pictures of what's going on, and then I always give them a copy of it when they leave, so they've got the data on that. All right, system static tests. Now, static tests are done by contractors to satisfy code or specified requirements and are documented by code acceptance or test reports. So there's many things that the code requires you to do, and these are static tests. Static tests may include building pressure tests, duct pressure tests, pipe pressure tests, pipe slope tests, flushing and cleaning tests, electric resistive and megger tests, bolted electric connection torque test, chlorination tests. Tests may be observed by the CXP, the owner's rep, or the general contractor for compliance. The CXP reviews the final test reports. On my jobs, I actually did not observe these tests unless was required to train the contractor on how to do those tests. The reason is when they need to do these, I'm not on site. And that's the problem. As a commissioner, you're not on site full time, and these tests need to be done immediately or else it's going to affect their schedule. So we normally had the GC be the the inspector on that, let them do the inspection and give us a report that is done, and then we're happy. And mainly, a lot of these are done by a sticker from the code authority, so we don't have to worry about it. We just want a copy of everything to make sure we get it in our report. Site observations. Okay, this is where you start to really do some performing on the job. During the course of construction, startup and testing, the CP performs site observations to verify construction activities are in conformance with the design and will not impact final system performance. Now, I know some of my colleagues who didn't do much of this. They said, this is no big deal. We'll catch all of these when we start actually testing the systems. And that's true, but boy, I don't like that. Having been a contractor, I want to catch things early. If I'm installing 100 systems identical and I make a big mistake on the first one, I'd like to know it so I don't duplicate that mistake 100 times. So I think it is not a wise choice to not do inspections. I think it's foolish. I think you need to do those. Site observations may include HV installation and startup tests, electrical installation and startup tests, plumbing and fire protection installation tests, fire alarm security installation tests. Installation observed for all systems include the Cx scope of work. So you're going to inspect those systems to make sure they're done correctly. Now, one of the problems with this is all those years ago when we first started commissioning, we made the assumption that the most junior guy could do an inspection. Not a problem, because it's just looking at everything, make sure it matches. Turns out it's exactly the opposite. The most senior guy and the most experience needs to do the inspections, because there's a whole lot of things that installation you can see, oh, that's wrong. Well, the junior guy just won't know it's wrong, and that's a problem. The process guys actually use the installing contractor to do the inspection, and that's worthless, because the guy who installed it, if he didn't know and installed it wrong, he's not going to know to inspect it that it's wrong. So that can't happen either. So it's a problem. So the CP performs several site observations during construction. When these site visits occur, it is important for the project commissioning schedule and the quality of the commissioning effort. So everybody needs to know about when you're going to be there. And then there should be some way of communicating when you're going to be there, because a lot of contractors like to walk with you, so they can tell right away, or to defend themselves if they have to. But normally, they like to walk with you so they know ahead of time. They don't have to wait for an issue log. They know exactly what's going on. So normally, you do a system installation at 35% rough in. So you don't want to be there before they start. That doesn't help anything. So at 35%, you're watching what they're doing to see if there's any issues you need to check out, or the contractor needs to know. A contractor should be very thankful that you catch an issue at 35%. It's going to save him money. System installation is 65% rough in. During the ductor pipe pressure testing, you need to see there once in a while. Before above ceiling or wall closures are done, you need to do that final inspection to make sure everything's done above the ceiling or in the walls before they close it up. The system installation completion to verify systems are ready for startup. This way you can kind of help the general with his schedule. I've seen it many times when I've been at the site and say, well, this thing's not ready for startup. And you go to the meeting and the general says, yeah, we're starting up tomorrow. And I go, no, there's no way you can start up tomorrow. And then, and the reason is because the GC is an expert at some things, but not all things. And normally they lack experience with HVAC and controls. They don't have the depth of knowledge to be able to tell if someone's blowing smoke at him, but you should. Installation observations are recorded on an observation report. Found issues are added to the CX issue log for resolution. And this report is a main communication component, and you need to make those observations so that the contractor understands what you do. And the main thing here is use pictures. A contractor will argue with words, but he won't argue with a picture. When you see something that's really dumb, that's not correct, doesn't meet the specs, or it's not industry best practice, a picture is what you need to use. During the course of the project, it will become necessary to have several commissioning meetings. It is best practice to keep these meetings as short as possible while still being able to perform the coordination required. Now, I've done a few jobs I've been many kinds of contractors, so I've been a mechanical contractor, and I've been a test and balance contractor on jobs that had other people commissioning, and the meeting just drove you crazy because they went on and on and on and on. With 20 people in the room, it took an hour and a half to do a commissioning meeting, a site commissioning meeting. And you just went, oh, God, this is terrible. You know, you just wasted all time. And it gave you the worst impression of commissioning because it was just total waste of time. I mean, that an hour and a half meeting could have been done in 20 minutes. So we want to make sure that what we do in a meeting is meaningful. It's not a meeting for us to prove how great we are. It's a meeting to say, this is what we see, this is what we need to have fixed, let's discuss it. That's what we need to do. Best practice is to have these meetings directly after the general contractor's MAP subcontractor meeting, since most contractors will already have a representative present. So this is what I came up with, what I thought it was a good idea, especially if I'm traveling. You know, I did jobs all over the United States, so if I'm traveled in to do an inspection, and I'd spend all day doing an inspection, the next day the GC has an MEP meeting, I'm going to slide in right after that meeting. I sit in their MEP meeting, and as soon as it's over, I take over and do a commissioning meeting. It works really well. The contractors like it because they don't have to go to another stupid meeting. I mean, some projects have a meeting every single day. It's laborious. So they will appreciate that. Review the open issues of the commissioning issue log. This is the first thing you need to do. Go over all the open issues. All the closed issues you can ignore, but the open issues we need to talk about. What's happening? When are we going to resolve this? What is it? You need to keep pounding this home. Review the check sheet progress. How are you guys doing? Are they done yet? Have you given them to me yet? Discuss future commissioning schedule activities. What do we got coming up? Answer any questions or concerns. And that's it. It's really a short meeting. But it can be important. The owner's rep needs to be at these meetings also because he needs to see what happens. And if there's some really important design questions on this issue log, you need to queue up the designer to have a representative from the designer there also. Okay, pre-functional startup tests are performed by the contractor in accordance with the project schedule and in conformance to the manufacturer's instruction. The CX team may observe these startup tests or may verify the startup from the startup check sheet's completion. Now, a lot of commissioners like to really be there and be a part of the startup process. I have no problem with that. I don't normally do that unless it's a controlled startup. But I mean, if it's a normal mechanical startup, I won't be observing. And the reason is, you know, I've done a lot of hands-on stuff in my life, and I can certainly start up a piece of equipment, but it's not my piece of equipment, it's not my job. And I don't bring a lot of expertise. If a manufacturer's rep is there starting it up, he should know 100 times more about that machine than I know. So I don't have to be there. I'm not going to bring anything to the party. I don't add any value. And I don't need to be there for anything I don't need to be add a value. Now, if he does something wrong during startup, we'll figure it out later. A functional test will bring that to light right away. The CX team should verify that all installation check sheets or readiness reports are complete prior to the system startup. So they should have already finished their pre-startup check sheets and should know what's going on with those. And if they don't have them done yet, they shouldn't be starting up a piece of equipment they're not ready. The CX team shall collect and review all startup reports. Now, sometimes these startup reports are on cloud-based systems, which is easy. They should be able to give you your code to go look at it so you'll know when it's done or not. System startup should be complete prior to performing any functional tests or test and balance work. And I can't tell you how many times we've done test and balance jobs where not only was it not started up, it wasn't complete. So we basically, if you actually did your job and everything was started up before the tab guy got there, he'd be beside himself because he's going to make more money because he doesn't have to have as many trips to try to figure out when you're ready for him. All pre-functional paperwork or online reports shall include in the final CX report. See training session CX3 for HC pre-functional tests. That's CX3 is the one that lays out how you do those, what they look like, what's in them, what's not in them. So that'll help you do that. Yeah, commissioning of control systems. Control systems are commissioned the same as the rest of the HVAC system, but have a few special tasks required by the technical CX process. Special tasks for a control system. Since every control project is basically a design build, a more thorough design and submittal review must be performed. So now, on the problem here is that mechanical designers, engineers, cannot know every detail about every possible control system on the market. They're basically laying out a performance contract in their documents. They're saying this is what we want it to do. These are the standard sequences we want to, but we're not going to argue about a lot of stuff because there's a lot of stuff we don't know. Now we're going to list what tolerances we need for temperature and pressure and what we want it to do, but the control manufacturer and contractor are responsible for providing a system that delivers that. So you need to actually do a design review of the controls and make sure it meets the design specification because it is actually a design build. Special design reviews must be completed by the sequence of control. For the sequence of control, best practice is to hold a sequence of control workshop between the owner, you, the design engineer, and the control system programmer to verify the exact sequence and to address any questions from any members of the workshop. Now, that doesn't need to be done really if it's a real simple system with, a few package units. It's probably not going to be necessary. But if you have a job that's really complicated and you've reviewed the sequences and you have a lot of questions, you're not quite sure how this is supposed to work, it's really important to put a workshop together because what happens, having been a control contractor, the programmer sits down and looks at these things and say, well, I can't actually do that. I don't know how to do that. So we'll do this way. I've done it this way before. And they'll make a change and not tell anybody because who's going to know? Are you going to go in and read the code? No, you're not going to read the code. So that's why we have a workshop. I've done many, many workshops, and sometimes it's really enlightening of how they get together. Now, one thing that as the commissioner you do during these workshops is you try to direct them into where you want it to go. The first thing I want to happen is I want the designer to accept the standard sequences from the manufacturer. Now, why is that important? Well, because those sequences have been fully tested by the manufacturer, and they'll work best. So if I can get that, the control contractor's happy because he already has that sequence, right? We're happy because it's been tested before, so we're pretty sure it's going to work again. Everybody should be happy, but the problem is designers tend to start with a clean sheet of paper when they're doing these sequences. And some of them come up with the darndest sequences that are very, very complicated. And with sequence of control, the KISS principle is always applied best, right? So keep it simple. Because simple means that the contractor can do it well, we as a commissioner can test it well, and the owner can operate it well. That's what we're after. So be careful about sequences. The engineer does not need to make up a sequence. Trust me, there's plenty of them for almost every occurrence out there already. And a place to start is the ASHRAE standard 36. But this actually works really well. 100% point-to-point control system test performed by the CXP and the control contractor. Now, when you see this later on, is we expect the control contractor to test his loop checks, that he's fully tested the system, his polarity is correct. And you're going to do another point-to-point test as a commissioning test. Now, a lot of people say, well, that's a waste of money. Why do we do that? Well, because the control contractor said he did a point-to-point, but I bet you he didn't. And having been a control contractor, I understand what happens there. And if you don't actually do a point-to-point test, you're going to end up costing you more money, costing the contractor more money, and it will not perform very well because you're testing more stuff than he does. You're testing point-to-point, and you're testing the calibrations of the sensors. Functional system tests using a control system performed by the control contractor verified by the CXP. This functional test is where we separate the men from the boys, or the girls from the women. This is what's hard. This is what a lot of people, I've had a lot of, when we've gone out and done a test, and a control contractor says, what do you mean you're going to test them all? I said, wow, he said, no one's ever tested them all. I said, yes, they are. This time we're testing them all. And there's easy ways to do that, so it doesn't take a lot of time. But still, they need to be tested. Functional testing is done on all systems that have complex sequences of control. The commissioner provides the functional test script to be used to prove functionality. The team, the CX team, shall observe all functionality tests. Normally the functional tests are operated by the control contractor. Functional tests may be manned tests where the CX, manual tests where the CX team observes the documents, each step or action and reaction of a sequence of operation or control. Now, our separate section will tell you how to do this. Automatic trend function tests utilize control data trends to document and prove functionality of all complex control sequences. So we use data trends to prove the system actually worked. A successful FAT means the system is ready for occupancy. See training session Cx-5 for HVAC system functional test. We actually go over how you create and how you write these scripts. That's an important lesson. You should look at that one. The commissioning issue log. The CXP creates, manages, and maintains a CX issue log. The log contains all issues discovered by the CX team through all stages of the commissioning process. A project may have separate design and construction issue logs due to the timeline of the activities. And sometimes the designers don't want any issues of the design being given to the contractors. Some contractors may be anxious to use that data to try to get changes later on. So we try to separate the two. And besides, the design is normally done 4 or 5 months before we get into construction. So we do the design review first in one issue log and issue that, and then do another for the contractors later on. The CX log shall change the description of the issue, date of review, drawing details, specification reference, location of the issue, discipline, resolution response for contractors, designers, or owners, responders' name and company. So we also have an observation report that goes with these, or else a picture in the issue log. So the issue log's online. You can put a picture with it so that you can have a complete description of the issue. If not, then we'll use a Excel spreadsheet for the issue log, and that coincides with an observation report with the pictures and descriptions in them. And, of course, data response. Even though the CXP manages and maintains the issue log, they do not have final authority on any issue final resolution. Remember, you don't have any authorities. You can't actually approve something. The CXP responsible for the issue log, create and maintain the issue log, provide recommendations for corrections, again, a responsibility, verify when an issue is resolved, that you can certainly do, notify the owner when issue resolution will affect future operability, maintainability, or functionality. What I'm trying to say, there's a lot of times the owner will not understand this to be an important issue, and he will ignore it. So that's not a big deal. But if it is, you need to make sure he understands how big a deal it is, because if he doesn't resolve it, then it's going to affect the performance of the building, and you need to tell him that. Who has authority over issue resolution? The designers have authority over design-related issues. That's what they're paying them for, so they have responsibility for that. The general contractor has authority over constructability or installation quality issues. Having been a contractor, poor quality drives me absolutely crazy. Because if you put up a system in the air, and you get there and look at it, and it's twisted and not level, and it looks terrible, I can't help myself. I have to take a picture now. As a commissioner, you're not supposed to be judging quality, but I can't help it. Now, if quality is going to cause problems down on, then you need to punch it. The owner has final authority over all issue resolutions. And one issue is the owner can resolve something that's not actually resolved. Sometimes you'll find an issue that is an issue, but it's going to cost a whole bunch of money to fix, and it's money that's not in the job. So then the owner may say, we're not going to spend money on that, just resolve it. And the owner saying it's resolved whether it actually is or not. What to do when a resolution is not performed? Ask to have the issue moved to the architect's master issue log. Now, why does that happen? Why you just add it to another log? Well, all logs are not equal. You as a commissioner, and this is a whole nother training session I've got, but the contract does not actually have in it about performance. You're not obligated No contractor is obligated for the system to perform. Now, people look at me like crazy. Say, well, that's crazy. No, it's not. If you build a building, it looks great, sort of works, but has lots of issues, it doesn't. No money changes hands, and that means it's not in the contract. So if what happens, but the architect's master issue log, it has money attached to it. Yours does not. So if an issue on your log doesn't get resolved, it's a problem, but no money changes hands, so no one pays attention to it. The architect's issue log, money changes hands. So basically, if you have an issue that the contractor won't fix or doesn't fix, and you get it moved to the architect's master log, his pay draws can be held up until that's fixed. It's really important. So what I always do is ask the architect, look, I've got a few issues I've not been able to get resolved. Can I move them to your log? Oh, and I've never had one object. Yeah, sure, why not? It's just that he doesn't have the knowledge to see that that's wrong, but he's more than willing to help. And this actually does work. Place the CX report executive summary as an unresolved issue. This you're required to do in the report anyway. Most owners don't like having a commission report that has unresolved issues in them, but if he was not willing to resolve the issue, then he gets what he gets. Activities during project completion. We're getting close to the end, so don't give up. Operation and maintenance manuals reviewed. And this is one of those work tasks that is not much fun, but it is important. The commissioning team shall review the pertinent O&M manuals after they have been approved by the engineer of record. It's really important that it be after they have been approved. The CXP shall review the O&M manual for the following. O&M covers the installation equipment or the system. Warranties meet OPR requirements. Now, this first one, you say, well, that don't make sense. Well, it does. A lot of times you get a document for the operation and maintenance of a piece of equipment. You look at it, and it doesn't even tell you what the piece of equipment is. It's for a whole range of 40 or 50 pieces of equipment. And you're sitting there, well, what applies to this piece of equipment? It needs to cover the piece of equipment that you've got on this job. It needs to have startup instructions, normal operating instructions, emergency operating instructions, maintenance instructions, shutdown instructions, and a troubleshooting guide. It needs to have a parts list that can be purchased if you need them in the future. It identifies who to call for service or parts. Now that sounds like the dumbest thing, but I can't tell you how many times we get a end of the project and the owner doesn't even know who to call to get a service call or a part for the piece of equipment. That's just not acceptable. And why a contract would not do that? I mean, this is future money, but you never know. Then owner training verification. Now, owner training is one of those things that normally doesn't get much attention paid to it. But you as a commissioner need to up your value by paying attention to this. Because what happens in the specification, they'll put in a general specification that says, provide 8 hours of training. Well, what does that mean? I mean, it's really a complicated thing, and it's all about the owner. So the commissioning team shall verify that all required training is delivered in compliance with the specification and commissioning requirements. Videotaping of each session may be required. Now, that's important for you to understand. You don't want to be that video person. It takes a lot of time, takes some equipment, takes some knowledge how to do that. And you should make sure that somebody else does that. And that's one of your specification. When you created those specs all during the first of the job, you should have made sure where that's at. Videotaping is really important, but it's hard to do. The CP shall include training documentation as follows. Training documents record that includes date, time, and attendees for each training session. And so they're taking that attendance sheet, and you record that, and those go in a report to the owner. Final copies of approved O&M manuals, final as-built submittal drawings, approved submittal shop drawings and manufacturer installation instructions. Classroom topics include what is covered under warranty and what is not, suggested service contracts, review how to obtain service, review how to obtain spare parts, who to contact for technical assistance, review the submittal and submitted drawings. Each training session shall include review of the O&M manual, instruction how to start up the system, instructions how to operate the system both during normal and emergency operations, instruct on how to shut down the system, instruct how to maintain the system, instruct how to recover from the failure modes, instruct on general troubleshooting techniques for common problems, hold a question and answer session. Best practice is to hold a classroom training session, then a hand-on training event where operators start, operate, and shut down the actual system or piece of equipment. Remember, this is training, so they need to know. Okay, before we go there, let's talk a little bit more. One thing, the owner needs to tell you exactly what he needs. What does his staff actually need? He doesn't, if he has 5 operators, he doesn't need to have all 5 operators go through a 2-day control class. I mean, he can, but really he should have 1, 2, or 3 technicians who are expert in controls. Those are the people that should go to it. And maybe the owner has 10 other systems exactly like this. So that training session might be able to be shorter. You know, they need to know where it's at in this building and what is happening, but they may not need to be trained. They may all need to be experts on it. So what we've always done is gone in with the owner, looked at all the training, and we've extended some and reduced some depending on his needs, so his people get better trained and the general contractor can not have an extended length of time. And it works really well. Commissioning report, that's your final communication on the project. Shall contain the title page, shall contain the project name and address, owner's name and address, commissioning professional's name, address and contact information. Certification page will contain the project name, the name of the commissioning professional and their certification stamp. Also include the project start and completion date and the commissioning scope of work. Any variance from the process standard utilized and should be clearly delineated. Okay, so what we're saying here, the certification page is the one where you're certifying that I commissioned this project and this report accurately reflects that commissioning effort. Now, as some of the certified people have a stamp, and it's a commissioning certification stamp. Others have just a PE stamp, can use that. But anyway, this page is a certification page. If you have no stamp, still need the page. Because what's really important in here is if you said you're doing this in compliance with the ANSI standard 110, and during this process, the owner asks you not to do something or to do something different, then you need to delineate that you did it differently in this certification page. So that if anybody comes along and said, well, you know, you didn't actually follow standard 110, you can say, yes, I did, but it's clearly delineated. We were asked not to do this particular thing on this project. Table of contents, an executive summary indicating that standards were followed for the commissioning of the subject of the project, and a list of outstanding unresolved issues. That includes a reason for each unresolved issue and a description of a resolution for the issue. So if there's unresolved issues, then you have an executive summary that actually says these are unresolved. And there may be reasons why something's not resolved, like, you know, we had to be a deferred test because the weather wasn't correct, or there's some other activity happening that precludes us from actually doing this test at this time, or other problems. I don't know what they could be, but you just delineate them here. Project final OPR, final commissioning plan, and by the way, the commission report comes quite large, and that's why we really like online reports, so that it can be as large as you want and people can have it and always have it from then on. Final commissioning plan, final resolved issue log, copies of field observation reports, copies of each check sheet complete by the contractor for each piece of equipment and system, copies of each functional test performed, complete with data trend or observed check sheet, copies of each test report completed and received from the contractors, training verification records, communication documents, copies of pertinent communication documents such as emails, letters, and reports, test instrument page. Now, we didn't actually talk about this, but one of the things in Standard 110 is that you as a commissioning have certified, calibrated test instruments. Now, if you need something really special, the contractor is supposed to provide those, but as far as a standard volume meter, standard amp meters, standard pressure instruments, standard temperature instruments, standard humidity instruments, standard CO2 instruments, you should have those. And the reason is the contractors on site have those instruments. If it's involved in their craft, they're probably not calibrated. And that's a big issue. The owner has them. They're definitely not calibrated, which is really irritating. But so you need to have those instruments so you can say they're definitely calibrated, and this proves that the system worked correctly. System manual. The system manual should contain title page. Now, a system manual is a document that has everything a person needs to operate the system and understand the system in one place. Otherwise, I realize nowadays we're all digital, so that makes it much, much easier. But sometimes not, because they don't know where to find the digital data. So we put it all in one place so they have it. Table of contents, facility operating guide. And the facility operating guide includes operator instruction how the system is to be operated in normal and emergency modes, set points, maintenance procedures, and predictive maintenance schedules. What you've done is you create the facility guide. It's really not as hard as it sounds. You take the O&M manuals you got and you lay out what needs to be done. And a lot of times the O&M manuals may not have everything because the things you're doing are cross systems. So you're doing set points and maintenance modes that may include many pieces of equipment or many systems, and you're giving, this is very helpful to operators. They know, okay, this is the way we basically need to operate it. It doesn't detail everything in the maintenance manuals. It just details the overall normal operating procedures and anything special we have to do. Approved control system submittals and as-built drawings. So the things that they're going to have to use all the time, we put in this manual. And approved control system submittals and as-built drawings and final sequences are what they really need. Key equipment submittals, copies of approved O&M manuals, copies of PDF drawings, copy of final tab report. Now, sometimes you get 400 or 500 meg. These can be really large files. Sometimes we have separated the things that have a whole bunch of data to them, or big, like the final O&M manuals. We put those in a separate section so that they can upload just the key things in the system manual, and in the second section, or have two. One is a abbreviated system manual, one is a full system manual. Activities after project completion. Deferred system functional testing. After project cleaning, any tests that are deferred due to weather or other operational issues shall be formed. All deferred functional tests should be documented as per the technical function test requirements defined by the commissioning team during the acceptance testing. Any issues will be added to the final issue log for resolution by the contractors. A warranty issue log. Prior to the end warranty of the project system, the commissioning team shall review all completed and outstanding warranty issues and create a warranty issue report. The commissioning team shall analyze these warranty issues to determine if there are any underlying causes from unresolved construction issues. Now, this sounds like it would be hard, but it's actually really easy. When you get that 10 or 11 months, you actually call the general contractor and ask him to share with you his warranty issue log. He has one. He keeps one. All the warranty work they do, he keeps track of all of it. He gives you a copy of that, and you just simply put it in a report. And maybe there's some other things that you put in there, but basically it's really simple to do. This is the warranty we had on the job. Now, if you've done a really good job and the contractor did a good job, there's almost no warranty. Because modern systems really don't break down much. I mean, years ago we had a lot of breakdowns because quality of our systems were not as good as they should be. But nowadays, systems are much better quality. Updated CX report. The CXP shall produce a CX report addendum that contains any deferred system test and the project warranty reports. And that's it. You made it to the end. Long, sluggy process. Sorry about that, but I wanted to put all the information, basic information, in one place. So I appreciate you watching. I appreciate you being a subscribing member. And have fun watching the other commissioning videos for the actual details of all this stuff. Have a great day, and I'll catch you on the next one. Thanks.